Oh, I feel back at home. I was doing, oh, let me check my mic real quick. I was using Vim. Mic was off. I was on the wrong setting. My buddy showed me these Vim motions key bindings that I guess are associated with some Vim IDE that some people use. But the idea, or I guess the fact that typing is not a massive part of coding, of making systems, of making things. It's the thinking about what needs to happen. It's not the speed that I can do it or that I can do whatever. I don't know. I think there was a video I was watching. There was this guy. He was talking about a guy sitting next to him who was typing and then clicking and typing and clicking and typing and clicking. Put a Vim guy next to him, and if he needs to take just as much time to think about things and he's not any more versed than the guy, maybe he's slightly faster total. No, I don't think you'd be slightly faster total. Because, I mean, I don't know. It just feels like it's not significant enough. I mean, I can make things fast enough. I mean, I would need like a scared straight moment where, Ethan, you could actually do this if you switch to Vim motions. I was learning it. I was playing a little game where you're moving around. And just not the syntax, but like how you move around and how the cursor moves and how to search and how to do this and that. Bro, I'm good enough at regular typing. Fuck off. I need like a full scared straight moment to make it be worth it. Okay, I don't remember the syntax for lambdas. We were doing this yesterday. I'm only doing another 13 minutes because I'm going to spend 30 minutes on C++ stuff total daily. Today I'm not going to do any quiz stuff. I'll just do this and whatever. So here we had a function. I think we were including what? Probably, algorithm, probably. Right? And oh, is it not find if? Is it actually just include? I mean, I think it was just array, right? Oh, is it standard find if? Yeah. Is it in algorithm? Oops. Yes. Okay. Like, that's just so much faster than having to press G, G, V, Shift, V. Bro, just give me Control A backspace. Done. The typing is not the issue at all. Allows us to define an anonymous function. Oh, you know what? That's the excuse. Bro, if you can type as fast as me, you don't need Vim. That's how it is. I don't type that fast, but I type fast. That's it. That's all you need. Okay, so the point here is when we're doing a standard find if, I guess we need algorithm, sure. Standard find if, and we're passing in whatever. Is it saying, is it different because it is. It's different if you do it here. Interesting. I guess there's an overload depending on where it is. I'm not sure how that works. So standard find if, we pass in iterator, and then the function that needs to return true in order for us to return where it has been found in what object and a pointer to where it is, an iterator. So instead of going and calling this separate function, so we create a function just to use here. And maybe we only do this find one time. If we do, we have to define a separate function just for this. It would be cool if we could just have some piece of logic in here that would loop through and be called for each of these, and boom, we're good. Simple, or similar to what I was thinking yesterday, where I said, it'd be nice if we could just make this inline and it automatically be inline expanded. Cool, but it would be cooler if we could just have it here instead of having to be here. The problem is that it's in global scope. Excuse me. It has to either be in a namespace or it has to be in a namespace. It's either in the global namespace or another namespace, and it's somewhere, and it prevents us from using this identifier. So it'd be nice if we could just put the logic in here so I can use find if. The problem is that find if is expecting a function pointer. It's expecting an address to a function. So we need to figure out a way to put it in the logic. Apparently there's specific syntax to define a function that is defined within another function. Okay. A lambda is a function inside another function, and it's anonymous. So it seems like we just use it. It's like an if statement almost. The nesting is important because it lets us avoid the namespace pollution. Yet because we're inside a function, we're not inside a namespace, we're in a function. And to define the function as close to where it's being used. Exactly. So instead of having to find it, instead of having to put it elsewhere and then know, hey, this is used one time in this function, over here, in here. No, we put it right here. We put the syntax, boom. Instead of saying, oh, hey, by the way, this is a function that's defined to go and find this. Oh, hey, by the way, this is the function that is used to find this, blah, 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 whatever. Okay. So, like, oh, this function is used to return true when searching a standard string for this nut suffix or substring. It'd be nice if we could just put that here. So, cool. The syntax is one of the weirder ones. The hell's a capture clause? Capture clause? Parameters. Okay, it's at least in parentheses. I thought it was in braces for a sec. I was about to flip. And then the pointer operator, the arrow operator, return type. Okay. Statements. So what is this going to look like? Is it going to be something, and then whatever it takes, in this case, I guess an array of standard strings, and then, or at least a standard string if we're passing them in element by element, which is, yes, it's elements, so we're passing one string in to check if it has nut in it. So we have, it's a standard string, and it's going to return a bool. The hell is the capture clause? What happens if I just type that in offhand? So we do whatever this capture clause shit is, but we'll say, oh, hold on. I have an at. No, I whiffed. It's like right here-ish. Okay. So we'll do, instead of that, we're going to do the parameters first. So we'll say int A, int B, and it returns an int. And it has logic. What is this? Hold on. Is it not braces? It is. What's happening here? Is the point that the capture clause can be empty? Is that the purpose here? So we say capture clause, and then we say int A, int B. Still no red flag under the under the brackets yet, so it seems like this might work. Ah. Oh. Hold. Oh. Oh. And so, where does this get returned? Is it something equals the call with A and B? How do we pass it? How do we call it? Is the capture the parameters? And what if we say int x? Well, I can't set it equal to this. There's a semicolon here. Huh. I don't know what this would look like when you're actually using it. Can be left empty, but it still needs to be braced, seems like, or bracketed. Still this damn nipple pimp. Okay, it's going away. I don't know how I had that kind of acne on my nipple, man. What the hell? Okay. Parameter list can be empty if no. The parameter list can be empty if none are required, and omitted entirely unless there's a return type. Really, meaning that we could just have a capture clause? And the return type is optional, and it will assume what? And if omitted, auto will be assumed, meaning it'll return whatever the value is if there's a return. Is there a return statement in it? See, because so far it looks. Oh wait, hold on. It said that. Wait, it says the colon goes on the inside. Is it true? Capture clause. Int A, int B, int and A. What's the issue here? It's missing this. Oh, is the point that we need to return? Return A. Hold. What's happening? No, it's missing it before here. It's telling me that it needs one here. What are you saying, bro? You bitch. Why didn't you put a semi there? Hello? Come on, Alex. Is it different in the C++ standard? In this case, it's okay because it's okay. And you have the function right here, so it's not like there's a function used elsewhere and it's auto, and then you have to go and see what the hell it's returning, and then see what's calling it, because maybe we don't know, because it's a template. It's a function template where we don't know what the arguments are, so we don't know what it's going to return, because the return's a template, or template type. We have no idea. It's a type. It's a type. Non-template type parameter. I guess that's what we call it, right? A non-type template parameter. Yep. Because if we were returning auto elsewhere, compared to here, maybe it's a pain. If it's right here and we just leave it blank, we can look, see what it's returning, done. That's it. Instead of having to go and find the function first. The function's right here. Okay. No name, we don't have to provide one, huh? A lambda with an omitted, no captures, an omitted return type, and no parameters. And the parameters, including the parentheses, are omitted too. Wow. So it's empty no captures, boom, boom. Wow. Because the point is that this whole thing just gets called. Oh wow, we actually do initialize it as that. So if it was alone, we would need to end the statement, but because it's in here, okay. So what if we said, I don't really want to do find if, seems boring. Okay, and then we're going to do something that takes a function pointer, I guess, right? Or, no, we just need an object. So what if we say x is, can I just assign it to be this whole thing? Oh, I have a second error, sketchy. So maybe it does actually need to be called. So what if we say, what if we make a function that takes another function? What does it take? It takes an int return. Oh, hold on. It takes an int returning function. Hold. How the fuck do we do this? Wait, hold. A pointer to it. So we're going to say an int returning function, right? and it's a pointer to it, and this pointer is called x. Okay. Oh, I guess I added return, huh? That was my issue earlier. Oh my! Scared me. Almost done. Hold. So we're gonna do, it's going to take an int, it's a thing, it's gonna be called x. So it takes a pointer to a function that returns an int. Parameter is pointer to function with no arguments, or with no parameters, that returns an int, okay? And so I could call do thing with, right? Is this possible? Uh-oh, have another thing. Hold. Wait, here it is. Omit the parameters. What if we do this? Oh! Oh shit. Hold on. Okay. And it's not actually returning anything. So what if we said, what if we made this void and made this void? Oh, syntax looks crazy. Okay, and in the syntax we return 3. Okay. And then we say, what if we say, we output whatever x returns. Bop. We'll get 3. Cool. Bop. Okay. Interesting. So now instead we pass that. What's something we would get one time? I'll come up with this example and then call it. What if we... thinking about getting the player's name at spawn. What if you somehow had a game where you never, ever, ever asked the player to type anything again, ever? I mean, I guess that would be like Dragon Quest, huh? Because you put in your name, or Pokemon, you put in your name and then you never type anything. Oh, I guess you can type in your party member names in your Pokemon. Fuck it, let's pretend you can't. Okay. We need IOStream because we're gonna print. No, we don't. Yes, we are, because we need standard character input. This is going to be program, or let's see, get user's name and print it. Super easy. Okay, we're just going to do, and it'll be a function that. Let's see, what else are we going to do? Because we're not just going to create a standard string and then extract to it. Because that's one line of code. It's one to create the standard string. And then the next line we extract to it. And then the next line we print it. And that's it. And I guess we totally already have that. That already exists. Well, we could do it in kind of an annoying way, right? So what if we made a standard string real quick? Okay. And then we will standard string name. Okay, and we're gonna say it's const because you can't change it. It's gonna be called standard string name. I almost did m name because I'm so used to classes. And what are we going to return? We're going to return a lambda, and it takes nothing, and it returns a standard string, right? It's going to be expensive, but a standard string, sure. So it doesn't create anything. Well, I guess it's going to create one object, and then it's going to copy it. So we may as well just extract it straight to the standard string. It's inefficient to do it this way, but I'll do it for this arc for just to see. So, and now we're going to do this. Okay. What the fuck is happening here? Oh, true, we need a semi. And what is the issue? It's just that we're not returning it. It's fine. Okay. So we're going to create a standard string called your name. And we're going to do standard character input extract, or really we're going to do standard, oh sure, we'll do it one line, or one word, character input extract to your name. And then we're going to return your name. Okay. Hold. What's happening here? Uh-oh. Is it the constness? No. Oh wait, what the fuck? What the hell is that? Okay, hold. Why am I not able to initialize it with a string? What if I take this out? No. Nope. So if I remove this, and I instead do it's fine. So why is it not fine here? This is a standard string that takes nothing. It returns a standard string. And in it, it creates a standard string, it extracts to it, and it returns it. Take. Oh, it specifically doesn't take a lambda that returns a standard string. Really? Even though if I did the exact same thing with an integer, int x, okay, what are we initializing int x with? It's going to be a lambda. So an empty, whatever the hell, container, what the fuck we call it. And it returns an int, returns 5, or 5. Hold. Am I being retarded? I think I am. Oh, well, 1, this needs a semi. And 2, what am I fucking up with the conversion here? What did I do? I just used it, did I not? The point is it's taking the function. It's something that takes a function. So I would need to call it, and there's no identifier for the lambda. So it seems like you only use the lambda in a case where it's basically being written as a long argument for a function that takes one, right? For example, last example and then I'm out. Okay, so we're going to say there's another function. It's just called void do thing. Excuse me. And we'll just make it simple here. I don't like that. Okay, and we'll say it takes a void pointer. And it's really a pointer to a function that returns nothing. It's not a void pointer. It's not a void. Yeah, it's not. A void pointer is a pointer to anything. This would be a void pointer. Or sorry, void pointer like this. Since x is a pointer to void, it's not pointer x because that looks like we're dereferencing x. This looks better, but we do have to put it next to x whenever we're doing void. X is a pointer to void, or rather we say pointer to void function. So void returning function, pointer to it. It's called x. It takes no arguments, has no parameters. That took you a long time, IntelliSense, Jesus Christ. Okay. And then we're going to say, we're going to call do thing with a lambda, but I'm going to type it on one line just to show that it's like making a function as an object in a function. Okay. So empty container. Is that called container? What is it called? Capture. I knew it started with a C. Empty capture clause. It returns nothing. And it has some shit. And we're calling it at the end. And right now it's empty. Returns nothing. That's it, actually. That's way easier than I thought. Okay, we're going to call x. Because x is a function. But could also be no, not a void pointer, because a pointer to void we can't just call. We'd have to dereference it, but we can't dereference a pointer to void. We can only use it, right, to store the address of anything. We said pointer to void called x. Can't just call it with the syntax. Can't call that. The expression preceding the parentheses must have a valid pointer to function type. Yes, it would need to be a pointer to function. But in this case, it's just a void pointer. We can't call a void pointer, but we can call a pointer to function. Sure, instead of having to, like earlier, well, I'll just type it out again. A void returning function, a pointer to it named x, and it's a function. We don't have to do dereference x and then call it. We luckily have the nice syntax of just, or oops, boom, call it. So we can't just call x as a void pointer, but we can if it's a function pointer specifically, not a void pointer. Void pointers can't be dereferenced anyways. So, oh, and let's see what happens if we do try and dereference the void pointer. So we're just gonna make a pointer to void called x, and we're going to simply if x, to make sure we're not dereferencing a null pointer, dereference x. Boop, here it comes. Womp. Pointer to void is a pointer to an incomplete object. We cannot dereference it. We can't do it. It doesn't hold a value. Okie doke. Rather, it holds a value, but we can't dereference it because we're only using the value it holds. We can't actually use the value via it. Okie doke. This works just like, all right, that's next. Pop, pop. All right, I'll upload real quick. Bye-bye.